All right, well, we're here with Doug Plata. Thank you very much for joining us today.
Sure.
So you have a very interesting idea and proposition to try to get out there that you would like to see happen, and I'm sure lots of people would like to see happen. Can you tell us a little bit about what your plan is and what your presentation is?
Okay, thanks. Basically, it's called LunarCOTS Petition, and it's an online petition. People can go to LunarCOTS.com and fill it out. Basically, COTS, I think a lot of people within the space advocacy world know what COTS means, Commercial Orbital Transportation System, but people sort of use it as a moniker for what NASA does in partnering between NASA and private companies to develop commercial space to the International Space Station in low Earth orbit. Basically, LunarCOTS says, hey, that is one of the most successful programs that NASA has. I think it's generally recognized. Instead of just stopping America's commercial space to low Earth orbit, why not extend it to include the resources of the moon? And in particular, the poles of the moon have ice. We now know that. And ice can be broken into hydrogen and oxygen and used for propellant. And so to be able to drive an entire cislunar transportation infrastructure between low Earth orbit, the lunar surface, and back and again would allow us to bring propellant from the moon to low Earth orbit. So that we don't have to lift it all the way from the Earth's surface. And so if we get inexpensive propellant in low Earth orbit, honestly, it opens up the solar system. I mean, the moon, asteroids, Mars, it would help tremendously.
Absolutely. So what would be the first initial infrastructure that would need to be set up in order to make this possible?
Probably really the first thing we need is a prospecting mission. But it looks like in 2015 we may already have that done on the ice at the poles of the moon. So that's sort of not part of the LunarCOTS programs. But probably the key component is basically, call it what you want, but it's a space truck that goes from low Earth orbit to the lunar surface and back again. And so I call that an OTLV, an orbital transfer and landing vehicle. That would be able to go all the way through those orbits and down to the surface again and back. When it's coming back to Earth to deliver water from the lunar poles to low Earth orbit, to depots in low Earth orbit, it would do aerobraking to be able to, so we don't have to expend all of that propellant to slow down to bring us back to low Earth orbit. So I would say the OTLV would be the very first, or I don't know about first, but it's the critical component of the whole system.
Now, once that is in place, how would the harvesting and collecting of the ice and chemically splitting it into the rocket fuel take place?
Okay. If we presume Falcon Heavy is going to exist and this OTLV is sized for that, then we can deliver about 9 tons of telerobotic equipment to the lunar surface. The equipment that would need to be delivered to go all the way from icy regolith, lunar dirt, to propellant requires these steps. It would be setting up power, so solar panels being set up. It would require probably what I call dexterous telerobots, things like a Robonaut 2. These are things with heads and cameras and arms, and they can be able to set things up and also do some level of repair. Then really the mining equipment would be a harvesting equipment, so an excavator, sort of bucket wheel or steaming it out in place. So that would be the first thing, and then after you get the icy regolith, then you haul it to an oven that just steams it out, very simple, and then with those volatiles, it does need to go through a distiller, so a lunar distiller, to separate out the water from the carbon monoxide from the other elements in there, and then, or other chemicals in there. And then electrolysis, simple electrolysis to electrically break the hydrogen oxygen into the propellant that reloads the orbital transfer and landing vehicle with propellant, so refuels it, plus throws in the payload, which is water, and then it can boost off from the lunar surface and go to L1 and then eventually on back to LEO and deliver water that can be used for propellant to low Earth orbit. The result is inexpensive propellant in low Earth orbit. And what this means is for anybody boosting satellites or anybody that wants to travel around the moon or to the surface of the moon or to an asteroid or to Mars, they've got cheap propellant sitting right up there. That's the goal.